So in lesson 2.3, we're going to learn about how to write conditional statements, so the if-then statements, and then learn about the converse, inverse, and contrapositive of those. So let's just start off first talking about what's a conditional statement. So a lot of times parents make conditional statements. If you do this, then this is going to happen. So it's an if-then statement in the form if P, comma, then Q. So the hypothesis is the phrase following if, and that we call our P. The conclusion is the phrase following then, which is our Q. So if P, then Q. So let's go ahead and circle our hypothesis and underline our conclusion. Again, the hypothesis, we're going to circle and it comes after the if. And then our conclusion is, we're going to underline and it comes after the word then. So if a polygon has 6 sides, that's our hypothesis, and you could put a little P up there if you want to. And then this is our Q, our conclusion, then it is a hexagon. Now on this next one, Tamika will advance to the next level of play if she completes the maze in her computer game. Now there's the if, so our hypothesis is actually right here. So it doesn't always come first. So we got to kind of keep our eye out. And then she will advance to the next level of play is the conclusion, our Q on that one. So if you want to try these next two, go ahead and try those on your own. And then press play again and check when you're ready. And hopefully you have. Today is Thanksgiving Day is your hypothesis, and then today is Thursday is your conclusion. And then it's an integer, and then number is a rational number for the conclusion on that last one. Kind of had those switched. All right, so in this next one, we're going to write our if-then statements with what is given. So let's go ahead and do if. And then we're going to put our hypothesis. A polygon has 5 sides. If a polygon has 5 sides, then it is a pentagon. And pentagon is the conclusion. So that's kind of the idea behind these if-then statements. So on this next one, if an angle measures 45 degrees, then it is an acute angle. So if you want to try this next one on your own, pause, try it, press play, and check when you're ready. If the figure is an obtuse triangle, comma, then it has exactly one obtuse angle. Now in this last one, it's kind of in that Venn diagram type part. So we're talking about our hypothesis is the inner circle there, and then the conclusion is kind of the more broad one. So if the animal is a blue jay, then it is a bird. So that's kind of how we would write that if it's kind of in this more Venn diagram type format. All right, so in this next one, we're going to determine if it is true or false, kind of like what we did in the last lesson here. So in this first box, it says if the last month was February, then this month is March. Goodness, if I could read. So if last month was February, then this month is March. True. When a rectangle has an obtuse angle, it's a parallelogram. True. So that's what makes it kind of slanted. If Miss Dawson teaches geometry, oh, not this year, she's not teaching geometry. So this first part is false, and then everyone has a C in her class. So when you have a false statement as just the hypothesis, but your conclusion is true. This is when it gets a little tricky. So to help us be a little less tricky on this one, I kind of copied our table here to help us. So this is false, and then everyone's not going to have a C in her class, so that is false. So it's actually a true statement when we have the false and false. Okay, so it gets a little bit tricky with these. So in this next one, we have 2 + 2 = 7. Well, that's false. And then a banana is a vegetable. Well, it doesn't even matter what that is, because if our first thing is false, then we're automatically true. Okay? When we have a false hypothesis. So false hypothesis, we're automatically true. False hypothesis, automatically true. So if two angles are acute, then they are congruent. Now in this one, we can think of two angles, but are they going to always be congruent? No. So if we can think of them not being congruent, making this second part false, so such as 25 and 45, those are two acute angles, but they're not congruent. So that is when it would be false. On this last one, an even number greater than 2 is prime. So we have an even number that's greater than 2 that's prime? Yeah. So this is true. Okay. Or sorry, false. This first part is false because an even number is never prime. So because this first part's false, we're automatically true. Again, that goes back to these special ones that P is false. So our automatic if-then statement is true. Okay. And we'll practice more of those. All right, so now we're going to look at what converse, inverse, and contrapositive are. So kind of changing around these conditional statements just a little bit. So what the converse is when we exchange, we're exchanging the hypothesis, if I could spell it right, hypothesis, and the conclusion. So we're switching those to be the reverse. So we're going to put the conclusion first, then the hypothesis. So that's called the converse. The converse. So the next one we're going to talk about is inverse. And inverse is when we use that negation. We're using the word not, or changing its truth value. So both the hypothesis and the conclusion, but we don't switch anything around. We're just saying the opposite truth value. Okay, so that's the inverse. Invert, I always think of like flipping a cup upside down, so we're flipping its truth value. So converse, switching. Okay, and then inverse, negating and saying not, changing its truth value. Contrapositive actually is going to do both. So it's going to negate it and switch the hypothesis and the conclusion. All right, so let's go ahead and practice doing that. So this first statement is going to be bats are animals that can fly. So our first just statement, we're going to write the if-then statement in this one. So if an animal is a bat, comma, then it can fly. So that is just our statement. Is that true or is that false? If an animal is a bat, then it can fly. Yeah, true. All right, so now what we're going to do is on the converse, we are going to switch. Switch the hypothesis and the conclusion, okay? So we are going to then say if an animal can fly, comma, then, oops, not a bath, it's a bat. Then it is a bat. There we go. If an animal can fly, then it is a bat. So we just switched the hypothesis and the conclusion. Still an if-then statement. Now, if an animal can fly, is it always just going to be a bat? No. What's an example of an animal that flies? False. That is not a bat. How about a bird? So you want to give that counter example if it is false. So this one we're going to say not. So we're negating. Negate. Not. Okay, so we're going to leave it as if an animal's a bat, then it can fly, but we're going to change it to where it's saying not. Okay, so I'm going to move, whoops, I didn't want that. There we go, clone that. So if an animal is not a bat, then it cannot fly, because we say not for both. And that is false, because again, if it's not a bat, then it cannot fly. Well, again, we can have an animal that's a bird, and that is a not a bat, and it can fly. So, all right, so now the last one, we're going to do both switch and negate. Okay, so what that looks like would be if an animal cannot fly, then it is not a bat. And that is true. All right, so if you want to try this last one on your own, you can go ahead and try that one, writing those statements. And then check when you're ready. All right, so double check that last answer. And I said hunters was kind of my counterexample for a couple of those last one. But a logical equivalence of a conditional is its contrapositive, and that's known as the law of contrapositive. So this one, the beginning here, our if-then statement, is kind of logically equivalent to our contrapositive, saying not and switching.